measures an angle of inclination, usually we call that elevation, of 36 degrees to an approaching airplane. So here's our first airplane. Notice it's lighter. It had an angle of elevation from the ground of 36 degrees. 15 seconds later, an angle of inclination
of 64 degrees. So notice that we have 15 seconds that have passed. Here's our airplane, and its new angle is 64 degrees. So if the airplane is flying at a constant speed and a steady altitude of 8,000 feet in a straight line directly over the observer, find the speed of the airplane in miles per hour. And notice at the end we're going to have to do some converting. So far, what do we know? We know the height, we know the angles, and what we need to find is this distance here. How far did he go in those 15 seconds that went by? So what would be helpful, since we know the law of sines, is if we knew some of these angles, especially this angle right here. It would also be helpful to know some of the other angles so that we can find out what our missing side is. Well, what would this angle be? We'll start there. Well, the full angle is 64, and this portion is 36. So if I take 64 minus 36, I know how much is left. We get 28 degrees. Okay, this outline triangle is the one we want to work with eventually because that's where our missing side D is located. Do I know any other angles? Well, if we go back to geometry, we're going to use a lot of geometry in this class. So notice he's flying at a straight line that's level with the ground. So the ground is parallel to his flight path. And in geometry, learned that if we have a transversal, is what we called it, a line that cuts through two parallel lines, then the alternate interior angles are congruent. So if this is 36, this angle would also be 36 degrees. All right, well that helps. So now we have two of the angles in our triangle. Let's find the third, because that will help us out as well. Well, what's left? Well, triangles have a total of 180 degrees, and so far I have a 36 and a 28. So go over here and do 180 minus those two angles to see what is left. I'm sorry, that's not the best mathematical way to write it, but we're finding their total and subtracting them. Okay, well there's 116 degrees left. So now we have our three angles in our triangle. That is going to help us out a lot. And so if law of sines, all I need is one of the sides and it will help me find the remaining side. So now we need a side. So we're going to do a little sidetrack here. Okay, if I can find the length of this side, I will be golden. So we're going to do a little detour right here. I'm going to change my color and I'm going to take that and move it over so it makes a right triangle. Okay, notice that's parallel, so that's the same distance still. So it will still be 8,000 feet. In our last unit, we studied trig ratios, so sine, cosine, and tangent. So if you have a right triangle, you can use opposite over adjacent, adjacent over hypotenuse, those things to find missing parts of a triangle. I have the side length 8,000 and I want the length of that hypotenuse right there. I'm going to go ahead and call it x. I know this angle is 36 degrees. I was told that. Okay. What am I dealing with here? Sine, cosine, or tangent? If we're working with this angle, I have this side and looking for the hypotenuse. The 8,000 and the x, what are they related to that angle? Well, x is the hypotenuse, we know that. The 36 degrees is across from the 8,000, so that's our opposite. So I'm dealing with the opposite and the hypotenuse. What trig ratio is that? That is sine. Hopefully you remembered sine. Okay. All right, now we're going to use that to find the length of our side x, and that will allow us to solve our triangle above. Okay, so a little sidetrack to get a little more information and solve this problem. All right, so sine of our angle, which was 36, equals the opposite side, which was 8,000, over our hypotenuse, which was x. I'm going to multiply both sides by x, and I'm doing that so I can get the x out of the denominator. So now we have x times the sine of 36 equals 8,000. If I divide both sides by the sine of 36, I will be left with our x. So I take out my calculator. X is 8,000 divided by the sine of 36. And I get that x is 13,610.4. I'm going to round to the nearest tenth, just like that. Well, what does that do for me? Besides cause some work. It gave me this side length, 13,610.4. Okay, and so I can see a little more clearly, I'm going to redraw the triangle we're looking at with our distance we wanted in the end. Okay, I'm just pulling it down so it's all those markings are not in the way. Remember, our top was our 15 seconds, and I wanted the length of that side. Okay, I know those angles, so let's put those in, 36, 116, and 28. I know that this side is 13,610.4. That's the one we just found. And I need the length of this side d. I know it's 15 seconds, but seconds is not a distance. So I need a distance here. But notice I can use the law of sines because I have a pair. I have the angle and the side opposite. I have side d, and I have the angle opposite side d. So law of sines, we do the side over the sine of an angle, and the angle opposite that was 116. And then we have equals the side I needed, which was d, over the sine of the angle opposite d, which happens to be 28. I want to solve for d. And multiply both sides by the sine of 28. I know this problem's probably seeming overwhelming at this point. There's a lot of steps, but we're going to get there. So 13,610.4 times the sine of 28 divided by sine 116. If we just calculate that, that will give us the distance d. And we have d is approximately 7,109.2. That's my distance. Are we done? Unfortunately, no, because that's not what they wanted in the end. Okay, we ended up with feet, and they want speed, and not just speed, but speed in miles per hour. And we have 7,109.2 feet in 15 seconds. So we need to convert that to miles per hour instead of feet per second. I don't know how we've done conversions in the past, but some people draw a line and section it off. But we're trying to multiply by ratios that will cancel our feet and seconds and leave miles and hours. So let's change feet to miles first. There are 5,280 feet in a mile. We want to end up with miles on top, so we put the 1 mile on top. On the bottom, we put the equivalent number of feet. Notice what that does is cancel our feet with feet, and we're left with miles on top. We also want to change our seconds to hours. Okay, we want those hours to end up on the bottom, so we're going to put 1 hour on the bottom. We need to get rid of seconds, so we put the number of seconds that are an hour on top, and that happens to be 3,600. Notice that cancels my seconds on top with my seconds on bottom. Only labels on top are miles. The only label left on top is hours, and that gives me my conversion. So now write down what you have left on top. 7,109.2 times 3,600 miles over 15 times 5,280 hours. Okay, if you calculate that, you will finally get your answer. So on top we multiply 7,109.2 times 3,600, okay, divided by, and put this in parentheses, 15 times 5,280, and you get 323.1 miles per hour, and we have an answer. So this combined a lot of things from past math classes and a lot of adjustments. We had to do a little side jobs, but we were able to work it out. Okay, when you have a problem like this, go one step at a time and make sure you watch for what they want in the end so that you go all the way to where they want.